Hello everyone, today is April 13th and we are working in chapter 11 now. So let's look. This is a little bit more not involved, but it's more graphic. We're going to be graphing lines and so on, which is very enjoyable to do that. So let's look. We want to read graphs. That is a big thing for those of you that are going into the business world, is to read graphs, and we want to work with linear equations in two variables. So let's look. We are looking at on page 765 at that, and let's look at problem number 2 here. Is that what we're looking at when we're talking about a linear equation? Perhaps let me back up here. A linear equation in two variables. A linear equation in two variables would look like this. Is ax plus by equal to c? And this can be written in any form. We have both the variables on the left-hand side, and the only stipulation here is A, B, and C are real, and this is called standard form. Standard form for a line looks like this. For example, ours might be 5x plus 7y equal to 13. We might have 3x minus 20y equal to 0. We might have something like, generally we don't start out with a negative x. It could be that way, but we usually multiply through and clear it out. So a whole bunch of things. X plus y equals minus 29. This is a plus here. I didn't mean to smudge that up. So this is standard form for a line. This is the first time you're looking at two variables, and our two variables are x, y. They're always in alpha order. Always in alpha order. The x is first, the y is second. Okay? Example, and this is called an ordered pair. It's called ordered pair because it has to be in that order of x first and y second. So that's what we'll be looking at, our ordered pairs. Examples of ordered pairs would be something like 3, 2, minus 1/2, 14, 0, minus 20. All of these are ordered pairs. So now let's kind of look at this. On page 765, if we're given x equal to 5 and we're given y equal to 7, the question says to write this as an ordered pair. It always has to be in the order x, y. Looking at C, we have x equal to 2/3, y equal to minus 12. We have to put the x first and the y second. It looks like that. So that is not a very difficult concept, but indeed it is an important, very important one, because that's what we'll be working with, our ordered pairs. Looking there, this is what also is, the whole chapter is important, the whole section about lines. We're looking at 3A, and we're given the equation 5x plus 2y equal to 20. And the question is 0, 10 a solution? That's what the question is. So remember, this is our x and this is our y. So all we have to do is substitute in 0 for x, substitute 10 in for y, and we want to know if we get 20. So 5 times 0 plus 2 times 10, does that equal 20? And the answer is yes. So the answer is yes, it is a solution. Looking at B, is 2 minus 5 a solution? This is my x and this is my y. There's nothing the matter with labeling things, giving yourselves a hint. So 2 times 5, 5 times 2, plus 2 times negative 5, does that equal 20? 10 minus 10, does that equal 20? Well, we're getting a 0 on the left, we get a 20 on the right, and the answer is no, it is not a solution. Not a solution. Let's look at C, minus 420. Here's my equation. This is my x and this is my y. So 5 times negative 4 plus 2 times 20, does this equal 20? Minus 20 plus 40, does that equal 20? It sure does. So the answer is yes, minus 420 is a solution. Now, looking at number 4, you're saying we have y equals 2x minus 9, and it doesn't look like what we said. You know, we said ax plus by equals c, which is what we have up here. This is actually ax plus by equal to c. But now we have y equals. This is a different form of a straight line. It's just a different form. Solving for 1y. We can always write it that way. This is a very useful way of writing it. Just to tell you the order it is, it's called slope intercept form of a line. And we'll get to understand what that word slope means as we go through these sections here, okay? But it can be solved for 1y like that. And our question here is, we're given the ordered pair 5, and then we need to find the y value. So this is x and this is y. So I'm going to substitute in the 5 for the x, and I get 10 minus 9, I get y equal to 1. So the answer is 5, 1. As long as you're given one of the variables, it's just a piece of cake to find the other one. Let's do one more like that, and let's look at 4C. And the reason I want to look at that one is because on this one we're given the blank first, and then we're given the 7. So this blank is the x, and the 7 is the y. So now I have to substitute this in over here. And I get 7 equals 2x minus 9. I'm going to add 9 to each side. 16 equal to 2x. I always want 1x, everybody. So I'm going to get x equal to 8, and my answer is 8, 7. If I want to check my answer, I would say 7, does that equal 2 times 8 minus 9, 16 minus 9? Absolutely. It does equal 7. Now, looking at, that was 4C. Looking at number 5 on page 768, number 5. And I live making tables like this. This is how a lot of my math works. And the question says complete each table given some of the values. So we're given 2x minus 3y equal to 12. Here's my table over here. I call this a T-chart. That's my name for it, a T-chart. And of course the x's go on the left and the y's go on the right. And what we're given is we're given a 0, then we're given a 0 for the y, and then we're given a 3, and then we're given a negative 3 here. So this is what we have. It makes no difference if we're given the x or the y. We always have the option of finding the other one. So let's look. This is x equal to 0. So I'm going to write 2 times 0 minus 3y equal to 12, minus 3y equal to 12, and divide each side by negative 3, and I get y equal to negative 4. So that minus 4 goes right there. Okay, and now I'm going to let y equal 0. I'm going to substitute in the 0 right here. So I have minus 3 times 0 equals 12. I have 2x equal to 12 and x equal to 6. And that 6 goes right here. So are you getting the gist of this? Not too difficult. That's why we did that whole section on evaluating, substituting in. Okay, we want to let x equal to 3. So I'm going to put in my 3. And that gives me 6 minus 3y equals 12. Subtract 6. Minus 3y equals positive 6. Divide each side by negative 3. And I get y equal to negative 2. And I'll put my negative 2 in right there. Okay? This is so important, very important to know how to make a T-chart. This controls our ability to write a line. Write the formula down. I am given y equal to negative 3. And now I have 2x plus 9 equal to 12. Subtract 9. 2x equals 3. Divide by 2. And x equal to 3 halves. Okay? So this is a T-chart. Very important. You need to know how to do that for all of our work with lines. And that's how we actually draw a line, is using those points there. So let me slide that up so you can see that again at the bottom. In class, it's very easy for some of you that just say, you know, slide that up, and then I can do that. So looking again, let's see how we're doing here, is that this is a tricky type question, but I feel I need to do it, is 5b. We're given the line equals x equal to minus 1. So once again, it doesn't look like It doesn't look like it's in this format, and it doesn't look like it's in this format. Well, it's solved for x here. So I'm going to make my t-chart, and how many points does it ask me to find? It says write maybe three of them. So I have two empty spaces. I'm given this one, minus 1, 2, okay? So I need to fill in the other ones, and I'm given the y values. So I'm looking here, and I say, well, there's no y for me to substitute in. What in the world am I going to do? This says x is always negative 1, minus 1, minus 1. X is always negative 1. So if I wanted a big, long table of values, the x column would all be minus 1s, and over here I could do 3, 4, 5, minus 7, minus 29, any number over here. Any number. As long as in the x column, x is negative 1. Okay? So our book only gave us this many, and we needed 1, 2, 3 minus 1s. That seems to cause a lot of confusion to students. And then C is similar, y equal to 4. I'm looking at my t-chart, x and y, and I have minus 3, 2, and 5. And I'm given one value over here. So look at what this says. It says y is always 4. So I don't need to do anything else. In this y column, I just have to keep putting 4, 4. I could keep putting it all the way down. It's always 4. Okay? And then what is in the x column? Well, these 3 were given to me, but in reality, I could write any x value down I want because there's no x in this equation right here. Okay? So important that you can do a t-chart. You'll see that as soon as we start graphing lines, how important it is. Now, let's look at this. The question tells us to plot these points here, and of course plotting a point is important to us. We have to do that correctly if we want to graph a line. We have to know how to plot the points. So let's look. And this graph I have here, it's a little bit, I'll turn it right side up for you, is that it's not perfect. In other words, the blocks aren't exactly perfect, but it's good for plotting the points. So let's just talk about an ordered pair. We said that if we have an ordered pair, it's x, y. And if the ordered pair is 2, 4, that's the x and that's the y value. So when we're wanting to plot this, this point right here is what we call the origin. So this is the x-axis, the vertical is the y-axis, and where they intersect is the origin. Okay? And so now, going to the right, do you see I have all positive numbers, but going to the left is all negative. Going up is positive, as if you were climbing a mountain, and then going down is negative, as if you were descending. Okay? So now we want to plot 2, 4. You're always going to start at the origin, This tells me 2 to the right and up 4. So 1, 2, stop, go up 4, 1, 2, 3, 4, and there is my point 2, comma 4. Let's say that we want to plot the point minus 3, comma 1. So I'm starting at the origin. This tells me left 3, up 1. Start at the origin, 1, 2, 3, stop, go up 1, minus 3, 1. Okay? And if we have something like this, if we have 1 minus 5, this means right 1, down 5. You always start at the origin. To the 1, down 5, 1, 2, 3, 4, 5. And here is 1 minus 5. So plotting points is going to control your ability to graph a line. So you need to know how to do that. Let's look then at the points that the author has on problem number 6. Okay? Let's look at what he has. And for A, he has 3, 5. So the way I interpret that is right 3, up 5. Okay? Start at the origin, 1, 2, 3, stop, go up 5, 1, 2, 3, 4, 5, and my point is 3, comma 5. Okay? Let's look at C. Let's look at C. Minus 4.5, comma 0. So this minus sign tells me to go to the left 4.5 and then stop, and then I do not move. Just stop. 0 means no up or down. So I start at the origin, 1, 2, 3, 4. 4.5 is halfway. I do not go up, I do not go down. This is the point, minus 4.5, comma 0. And then G, this 0, 0 is what we call the origin. And it tells me do not move right or left. It tells me to not move up or down. And it's right here. This is the origin. 0, 0. And then F is 0 minus 6. This tells me no horizontal move. And then it says down 6. Down 6. So do not move right or left. 1, 2, 3, 4, 5, 6. 0 minus 6. Okay? So you have to be very proficient at plotting points in order to work on graphing lines. Okay, I'm in the dark again. They turn off my lights constantly. So you're going to need a straight edge when you do your and mine got moved somewhere, my straight edge. But let's just look, and I'm going to go turn my lights on, is that we always have an x-axis and a y-axis, and we need to name these. We have 4 locations. They're called quadrants, and this is quadrant 1. We're going counterclockwise. This is 2, this is 3, and this is 4. So 4 quadrants, and they are labeled with Roman numerals. Okay? This is something you need to know. I would probably ask you to label the quadrants. I'm going to ask you to plot points. Somebody just helped me out and got my lights back on, so now I can see again. So I'm going to ask you for this. I'm going to ask you to plot points. So you want to make sure that you are on top of all of that. So that would refer to what you need to know. And then looking back on page 769, and we're looking at the points 3, 5, minus 2, 6, 6 minus 2, 0 minus 6. We just look at all those points there because I see how he asked the problem differently anyhow. So it says to name them. So in quadrant number 1, both the x, do you see the x is positive, going that way, the y is positive. So you're looking at the points that have 2 positive. Okay, that'll work, and that is it, is that one there. Quadrant 2, this is negative on the x, positive on the y. Negative on the x, positive on the y. So that's going to be minus 2, 6. What about minus 4.50? Well, anything that's on the horizontal or the vertical axis does not have a quadrant. And what else? No, yes. And we have minus 3 comma 5 halves. Okay? Quadrant 3, x is negative, y is negative. So I'm looking for 2 negatives, and that would be d minus 5 minus 2, and that's all that is both negative. Quadrant 4, this is positive, going down is negative, so I'm looking for x positive and y negative, and the only one we have is minus 3 comma, x positive. That's not positive, not at all. So I want x positive, right here is 6, y is negative, and I have 6 comma minus 2 there. So we're saying, well, what about some of those other ones? They didn't end up getting into a quadrant. This is what we need to realize, is if the point is on the horizontal or the vertical axes, such as minus 4.5 comma 0, such as 0 minus 6, such as 0, 0, these 3 points do not have a quadrant because they were on the line. One was here, one was down here, one was here. So we call them no quadrants. But the rest of them we were able to put into some quadrant. Okay? And looking at page 770, let's see, did I flip too many pages here? I did. So we were on 769, and I flipped too many. And let's look at this 771, and going on down. So let's look at the problem set for section 11.1. So this is really pretty much fun as working with lines. It isn't quite as, we're not computing as much as we have been. Look at that lower graph there, and it's all in quadrant 1, and it goes like this for the most part. It goes up, and then it isn't quite like that, but for my purposes, we'll just do that. So what I just want to explain to you is that going from left to right, we call that my curve is increasing. And this point right here, the x value must be 2010. Okay? And then looking here, this is called decreasing, because as you go from 2010 to 2015, my y value is going down, 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 down. So determine increasing and decreasing, we're only looking at the y value as you move from left to right. Okay? As you move from left to right. So that's what tells us increasing and decreasing. Now, let's check out problem number 14. Number 14 says, what is the general trend in the unemployment rate between 2010 and 2015? Well, this is 2010 and this is 2015. Does everybody see that it's declining, declining, declining? So that was good news. Unemployment was declining. Declining. Okay? Unemployment, or you could say decreasing. Those two words would be the same thing. It is, the rate was decreasing. Okay? So we want to have an idea if something is growing or if it's getting smaller, increasing or decreasing. Those are things to have an idea on. And let's look at number 24. Number 24, page 772. And we have 2x plus y equal to 5. And the question says, is this a solution? 3 minus 1. Well, I don't know, but give yourself a little hint there. 3 is the x. So I'm going to have 2 times 3. I'm going to have plus minus 1. Does that equal 5? Well, 6 minus 1 equals 5. The answer is yes. It is a solution. Okay, that's how easy it is. You just substitute in. Let's look at 26. 26. We have 4x minus 3y equals 6. And the question is 2 comma 1 a solution? So I'm going to label it, so I substitute in correctly. And I have 4 left paren 2 minus 3 times 1. Does that equal 6? Well, I have 8 minus 3, and we all know that's 5. 5 does not equal 6. It is not a solution. Okay? $34. This would kind of give you folks an idea of taking an online classes. is that, you don't have any interaction in your classroom. So I prefer interaction. I think it's a good thing to learn from other people. But this shows you the challenges of that as well. Looking, we have number 34, we have 0, comma, and then we have a question mark. And it refers to y equals 2x plus 7. And it says, replace that. What should that number be? Okay, so this is my x. So I'm going to put in 0 for x, and I get 7. I get y equal to 7. So that becomes a 7 here. Okay? Number 40. Our line that we're working with is y equals minus 4x minus 4. And I have a blank comma, and I have a 24 here. So in this case, I need to find the x value. This is my y. Remember, I need to find x. So I'm going to substitute 24 in for that y. And I have 24 equals minus 4x minus 4. I'm going to add 4 to each side. The 4's add out. 24 plus 4 is 28. We need 1x, so I'll divide each side by negative 4, and I get x equal to minus 7. So that's the value that goes in there, minus 7 comma 24. Okay, this is what I need to see. I need to see you writing down the formula, showing the substitution, and then solving. That's what we need to see. 42. 2x plus 3y equal to 12. I have a t-chart. On my t-chart, always write your x and y in. And we were given a 0 here, a 0 here, and an 8. So we needed to find 3 values. So I'm going to let x equal to 0. I'm going to divide by 3, and I get y equal to 4. So 4 is the number that we found. Now I'm looking and I'm saying, well, what am I going to do here? Well, this is under y, so I'll write my formula down. I'm going to substitute in a 0 for the y, and I get 2x is 12, x is 6, and that number goes right here. Okay? And then my last one is y equal to 8. So I have 2x plus 3y equal to 12. I'm going to substitute that in for y. I have 2x plus 24 is 12. Subtract the 24. We get 2x is negative 12. X is minus 6. Okay? If I had got 6 here, I would go back and find my mistake. We can't have a 6 here and a 6 here in 2 different y values. We can have a 6 and a minus 6. That's perfectly legal, but they cannot be the same. Okay? Not for this problem here. Okay? How about 46? This is the one I told you that's tricky, everybody. We have our t-chart. What does this say? This says x is always 12. X is always 12. So in this column, I'm going to put 12, 12, 12, 12. I could put down a large number of 12s. In this column, on 46, he gave us the 3 and the 8 and a 0. He gave us those. But in reality, this could be any number at all. Could be any number. You know, I had picked something else. You know, I could pick 1, 2, 4, minus 1, minus 2, minus 4. This could be any number at all. Okay? The 48 then, so this is warming us up. We're going to actually have to graph that at some point. This 48 works the same way, folks. And we're given y equals minus 10. What is this saying? Y is always negative 10. And he gives us 1, 2, 3 of them. 1, 2, 3. And the directions had said, complete each table. Oh, and he said to write it in ordered pair form. Usually I just am looking at it in this form here. I don't need the ordered pairs, but ours would be 12, comma 3, 12, comma 8, 12, comma 0. Okay, the T-chart is good for me. That's what I like here. So now we have y equals minus 10. I could have a numerous number minus 10. And we want to know, well, what are we going to put in for y? On number 48, y is minus 10 all of the time. What are we going to put in for x? And we could put in anything we choose for x. So he doesn't give us any hint there. So you could pick any number at all. You could pick 1, 2, 29, or you could pick these numbers here. That's always true. Okay? 66. Looking, plot each point on the rectangular coordinate system. Okay? So we have a rectangular coordinate system is a graph, and you need to know that's x and that's y. And our question says on problem number 66, we have minus 3, 5, and he says to plot that. So give yourself a hint, x and y, so that minus 3 is left 3. The y tells me to go up, and this would tell me up 5. Left 3, up 5. Okay? So left 3, 1, 2, 3, stop, go up 5. 1, 2, 3, 4, 5, stop. And here's our endpoint, minus 3, 5. And then you need to do a, I don't think we have to graph it, but the question says to do what? Plot each point in the rectangular system. So we did what he asked us to do. 74, same thing occurring. Plot this point, minus 3, 0. So this is x and that's y. So I'm starting here at the origin. I'm going to the left 3, 1, 2, 3, and then I'm not going up or down. So that will save that, and it doesn't tell me which direction to go in. So we have minus 3, We're not going up or down. Minus 3 comma 0. Make sure that, 7, we're on 66. Whoops. Minus 3, 5 we plotted, and then 74, we're at minus 3, 0. So this point right here is the point minus 3, 0. Do not move. Let it right there, but do not move it up, down, right, or left. Okay? And then one thing pertaining to lines. 78, let's look at that. 78, we have 2x minus 5y equal to 10. My chart looks like this, and we have 0, we have 0, we have minus 5, and we have minus 3 for the y. The directions say it says complete each table of values, then plot the given equation, then plot the given ordered pairs. Okay, so we need to fill in these spaces here. We have 2x minus 5y equal to 10. When x is 0, you basically are holding your finger over that, and you get minus 5y equal to 10. Should be pretty much like your plan. So I'm going to have 2 times 0 minus 5y equal to 10. Minus 5y is 10. Divide each side by a negative 5. Positive and a negative is negative 2. Are you following that, everybody? Okay. So now we have 2x minus 5y equal to 10. I have a 0 here. Should I substitute that in the x position, or should I substitute it in the y position? Well, since it's under the y column, we have to substitute it in the y location. So we have 2x equal to 10, and I'm going to divide each side by 2, and that's going to give me x equal to 5. Okay? So I wouldn't surprise you and just throw something in that you haven't had in class. That isn't what my style is. Okay? So that was section 11.1, everyone. And we will just go forward then, and we'll do 11.2 graphing lines. Graphing lines. So what you need to know is that this is not the only way to graph a line, but it's the easiest way, is that you need to be given, so you need 2 points. You need 2 points to graph a line. Now this is not the only way to do it. Does everybody understand? There's another way you can do it, but this is a good method, is graphing a line. You need 2 points, an x value, and you need a y value. So let's look. A very important idea are the X and Y-intercepts. So very important. And you're saying, well, what in the world is an intercept? That means where it either crosses the x-axis, the y-axis, or both. Okay? So let's look. We want to, I don't know if I headed in here. Oh yes, I did head in. the 11.2 is that we're going to head in talking about something that are called the intercepts, X and Y-intercepts. So let's look. And I'm going to put this out there. And I'm going to put this in. And something over here. So you see the 3 points aren't going to line up, so we're not trying to make them line up. So let's look at this line right here. And this line is helpful, okay? It's just the vertical axis. So the question says look at the intercepts. So let me make this point, let me make that a 1 and let me make that a 2. Y equals 2, x equal to 1. Let's say it's 1, 4. And here we have 0, 3. Okay? So now, the location where it actually intercepts the x-axis is called the x-intercept. Okay? Where the graph crosses the x-axis is the x-intercept. And he has a nice little box for you on page 779. So I have one x-intercept. I have an x-intercept. We only have one. We can't have two. So the x-intercept is equal to this number here, which is a 1. And the intercepts that, well, we only have one x-intercept, so we're done. Just it's x equal to 1. That's how easy it is. Now the y-intercept, this is the x-intercept here. So for whatever reason I have down here, I have 0, 4. I don't know how in the world that happened. I must have been doing another problem. So this problem, this point here is 0, is 1, 0. 1, 0. I must have been looking at something else. Okay, so that is the x-intercept. I don't think a lot of cell phone users, if they want you to look at something on your phone, is that you can't do things like this, but you certainly can do the arithmetic piece here. So this one said x equal to 1, which I had. I don't know why that 4 was there. And my y-intercept, that means where it crosses the y-axis. This is the y-intercept, and we get y equal to 3. So let's review that. The x-intercept is where the line crosses the x-axis. The y-intercept is where a line crosses the y-axis. Okay? So let's look at this. At the x-intercept right here, look to see what y equals. For the x-intercept, where the line crosses the x-axis, what is the y value all along this line here? No matter where it is, it's always 0. So I would put here, let y equal 0, and that would let you find the x-intercepts. Now when our line crosses the y-intercept, let's look, what is the value all along this line right here? Does everybody agree that the x value is 0 because it's not to the right or to the left? That's exactly correct. So we're going to let x equal 0 to find the y, y-intercept here. Okay? Find that to find the y-intercept here. And do you see it's very visual, but you still need to know how to do that. You need to know how to substitute in 0 and get the x and the y-intercepts for sure. And we're going to do some of those. Let's look. Let's say we were working with this line quite a bit this morning. So let's just look at that line. If the question is to find the x-intercept, what you have to do is you have to let y equal 0. Because you look at your graph here, the x-intercept is where y equals 0. So what I'm going to do is I'm going to substitute in 0 for y. I get 2x equal to 12, and when I divide each side by 2, I get x equal to 6. So the x-intercept then is x is 6, y is 0. Let's do a check. 2 times 6 plus 3 times y. Does that equal 12? Sure does. Okay? So you let the opposite variable equal 0. If we want the y-intercept of this exact same line, 2x plus 3y equal to 12, if we want the y-intercept, look at your picture. Do you see that all along this line here, no matter what, the y value is, we want the y-intercept. So does everybody see that the x value is 0 all along that line there? Okay, no matter where you are, the x value is 0. So you want the y-intercept, so you're going to let x equal to 0. And we have 2 times 0 plus 3y is 12. I'm going to divide each side by 3, and I get y equal to 4. So some people say y equals 4 is the y-intercept, and some people say 0, 4 is the y-intercept. It's up to you. Both of those notations are 100% correct. You just need to understand what an intercept is, and you need to find it. So I know why I saw 4. I was doing a different line here. So now let's look. Let's look at, we're on 11.2 here, and it's impossible to see in the dark. Page 780, we're looking at 4, and we have this equation here. And the question says, find the x and y-intercepts. Okay? So to find the x-intercept, you're going to let y equal 0. So that's going to get me 5x plus 2y equal 10. I'm going to let y equal 0. I have 5x equal to 10, and that gives me x equal to 2. Okay? So y-intercept equals 2, or you can write it as, oh, wait a second, I'm sorry. It says x-intercept. The x-intercept equals 2, or we could write it as an ordered paired 2, 0. Both of these are 100% correct. Okay? So to find the y-intercept, you're going to let x equal to 0. So here's my equation. I'm going to let x equal to 0. So I get 5 times 0 plus 2y is 10. I'm going to get y equal to 5. So my y-intercept is y equal to 5, or you can write it as 0, 5. Both of those are good. Probably those 2 points are the, they definitely are the most important points on your line. We're always asking for the x and the y-intercept here. Okay. And let's just do our couple exceptions that we've talked about while we're talking about intercepts. We have a line like this, and my other exception is this line right here. So let's look. Does everybody see that this is the x-intercept? Okay? X-intercept. Look at this one here. Does this line cross the x-axis at all? Does it cross it? No way. So this has no x-intercept. There is none. Okay? Then let's look. Let's draw this line over here. And we'll draw this line over here. And let's look. This horizontal line does not have an x-intercept, but it does have a y-intercept. Okay? Has a y-intercept. Look at this line right here. It has an x-intercept. The black refers to the black. I should have written 4 of these. This is too confusing for you. I don't like that. Should not have done all those on one graph. So let's do this. Let's do them totally separate. Okay? There's no x-intercept, but there's a y-intercept. Okay? This is the y-intercept, but I do not have an x-intercept. Okay? Let's look at this graph here. Okay? So this one has an x-intercept. Okay, it has an x-intercept. But does it have a y-intercept? Does it cross the y-axis? No. So no y-intercept. Okay? So let's just ignore these because writing 2 on one axis is too confusing. Look at it this way. This is much easier. Okay, so now you know about intercepts, and these are very important. This edition of the book emphasizes it more than our former edition. We used to have an older edition, and I don't even know if they mentioned intercepts at all. So let's look. It does ask us about an intercept. Is that I am on page 782. I'm looking at number 7, and it says to graph y equal to -5. So I make my t-chart. I'm dependent on that. This says y is always -5. So in the y column, I'm going to put loads of -5s down. And in the x column, I can write any number at all, 0, 1, 2, 3, because there is no x in that equation. So then when I graph this, 0 minus 5 is right here. 1 minus 5 is right here. 2 minus 5. 3 minus 5. I have all the points there, and they look like that. So the question says, is there an x-intercept? Well, there's no way it does not cross the x-axis. The answer is no, not at all. And then let's look at 8a, x plus 4 equal to 6. Well, I have to simplify that. I have to subtract the 4 first in order to see what it looks like. So this says x is always 2. So I'm going to put 2, 2, 2, 2. And in the y, I could put down 1, 2, 3, 4, 5, whatever I want. Okay? So when I graph that, x is my horizontal, y is my vertical. I'm going to plot 2, 1, 2, 3, 2, 4, 2, 5. Remember, 2 points determine a line. I don't need to plot 5 points. 2 points will do the trick. And a third point is usually the check, but you don't need 5. So now we have this graph right here. This is actually x plus 4 equal to 6, or x equal to 2. Okay? And the question says, is there, I can barely see, it says, well, it doesn't. It says, what is there? There is no what axis. So we have, not axis, intercept. So I have an x-intercept. I have no y-intercept. There's no way it goes through this y-axis. It just goes through the x-axis. So those two are like the exceptions, but every single instructor asks those on every single test, and you're going to see it in Math 1100 and in Math 1150 as well. So we start out here. You're getting a huge background to get into Math 1100 on all of this stuff. So looking then, let's look. We are in 11.2, and let's look on our problem set here. In our problem set, let's look at number 24. And number 24 says graph this line minus 3x plus y equals minus 6. Well, I know that some of you have taken algebra before and you want to use a different method, but right now we're doing a T-chart. So this is what I would like you to use. And to tell you the truth, we don't want to make this harder. The very easiest points is to let x equal 0 or y equal 0. Those are the very easiest. Why? Because look at this. I can do what's called the cover-up method. When x equals 0, I immediately get y equal to negative 6. Okay? Or you can say minus 3 times 0 plus y equals minus 6, and you get y equal to minus 6. I think I'm going to make that in green here. Okay? Put a little green in there. And then here, my y value is 6, so if I do the cover-up method, I'm going to cover up the y, And I know that if I divide minus 6 by minus 3, I'll get a plus 2. So the reason I like doing the X and Y intercepts is because we can do the cover-up method. So also, minus 3x plus y is minus 6. I'm going to substitute in a 0. I'm going to divide by minus 3, and I'm going to get x equal to positive 2. This is enough. You can get your line by just plotting those two. Now, those of you at home that have graph paper, you know, yours will be nice and neat, okay? You can download graph paper on your phone or your computer. 1, 2, 3, 4, 5, 6. Or you can just buy a tablet of it, or you can do what I'm doing. This takes a little bit longer. You might want to have some graph paper. So here we have 0 minus 6. 1, 2, 3, 4, 5, 6. Here we're at minus 6, but you didn't see that on there, so we have minus 6 is right there. And then we have x equal to 2. 1, 2, that's my x. This is my y. And this is my point right here. 2 points determine a line. And we have this. So my suggestion is go big, everybody. Go big. I don't like little tiny graphs. So this is minus 3x plus y equals a negative 6. You must label the axes. You're going to plot the points, and you're going to label the line that you graphed. Because remember, this is a visual aid. You're handing it to your employer or to somebody, and they're reading it. We use a lot of lines in business. Okay, graphing lines is fun. It's not that hard. It's not as tedious as some of the problems that we've been doing. Let's look at 32. 32 says, okay, 32 says y plus 3x equal to 0. You can leave it this way, or you can probably solving it like this, taking the 3x to the right. This is a little bit easier. You can do it this way as well. It's up to you. So our t-chart, I see that if I let x equal to 0, y is going to be 0, no matter if I substitute it in here or if I substitute it in here. So you want to pick another point, but you don't want to pick the number 1 because that's just too close to x equal to 0. So why don't you either pick 2 or pick minus 2, something that give you some good notation. So if I let x equal to 2, I would have minus 3 times 2, and I would get minus 6 here. If I use minus 2, I would have minus 3 times minus 2, and I would get a positive 6. You may use this, or you could have done it over here. If you let x equal to 2, you would get y plus 6 is 0, and y is minus 6. Same thing for the minus 2. Okay? So we have 3 points, and we only need 2, but the third one is our check. So we're looking at this. And we need the origin. Okay, we all know where that is. And I'll probably plot all 3. 1, 2, 3, 4, 5. I don't need all those. So 1, 2, 3, 4, 5, 6, that's a positive 6, and we need negative as well. 1, 2, 3, 4, 5, 6. So here I have the origin, 2 to the right, down 6, right here, minus 2, go up 6, we're up here, okay. So I know that my origin is correct. This is a little bit off. There we go. It has to go through all 3 points, everybody. And then my equation is y plus 3x equal to 0. Remember, label your axes. Label some units of measure. You don't have to put down 1 through 6 here. But if you give me the grid 2, 2, minus 2, minus 2, then everybody knows that each tick mark was equal to 1 unit. Okay, looking forward here. That was problem number 32, and we're going to look now at 36, and let's see what we have here. Okay, so we've done this problem, y equal to 3, x and y, 3, 3, 3, 3, 1, 2, 3, 4. Pick any numbers you want, okay? So remember, y is always 3. Students forget, or they skip this problem, and then when they go to graph it, I get points all over the place, but it's really very simple. Y is always 3, so we have all these dots like this. No other choice. So it looks like this, and we get y equal to 3, looking like that. Okay? I hope you're getting the gist of this, and that it is a nice relief from just doing computation all of the time. So 38 would be the same thing, only vertical. So 38 would end up looking like this, x equal to 4. My t-chart is 4, 4, 4, 1, 2, 3. And my line is going to look like this. 1, 2, 3, 4. Right here, I'm going to have 4, 1, 4, 2, 4, 3. And here's my line, x equal to 4. So it's easy, but you have to practice these for sure. Let's look now at, I actually like this problem number 45 where you match them up. So do that in your homework. And I am looking at number 54, folks. Number 54. A gas station is selling gasoline for $3.50 per gallon. Wow. And charges $7 for a car wash. The cost, Y in dollars, for X gallons of gas looks like this. Y equals $3.50 times X plus 7. So that's the car wash, because you only get one car wash and it doesn't change value. And this would be the number of gallons, and that will give you the total cost. So the question says, what is the cost if you buy 9 gallons? So you're going to buy 9 gallons. So that 9 is going to go in that position. Y equals 3.5 times 9 plus 7. So 9 times 5 is 45. Carry 4. 27 and 4 is 31. and it's going to be $31.50 plus 7. So 31.5 plus 7 is $38.50 total. Okay? So that equation gave us our total cost, given that the car wash does not change in value. It stays at 7. So that completed 11.2, and we have 11.3 to do yet today. So just give me 1 second here, and I'm going to go get the lights turned on in my room because I don't like working in the dark, and I will be right back. Here. What was on the floor here? Okay, so this is crazy that every time I want the lights on, I have to get up and walk around. So let's look. Let's look at what we're doing here. So we have 11.3 yet, and 11.3 talks about the lines. Okay? So lines are good. 11.3. The slope of a line. Oh, knowing the slope is so important. It gives us a lot of information. A lot of information. So what we're doing is we're looking to see how a line travels, and we always read from left to right. So we see that this one going from left to right is the y value is getting larger, so this slope would be increasing or positive, and this one going from left to right, the y value is going from high to low, so this is decreasing or a negative slope there, okay? That is a big idea, to recognize if the slope is positive or if it is negative. We have different definitions for a slope, and I want you to just grab onto the one that you like the best. So for those, you probably took some algebra in high school, and you said slope was rise over run. That sure is a good one. We replace the word slope with that small script m, and we can say the change in y over the change in x. Okay, that certainly is a good one. And the change in y over the change in x can be written as, look at the ordered pair, x1, y1, and x2, y2. So the slope of the line going through those 2 points is y2 minus y1 over x2 minus x1. So students, this is what's called a subscript, everybody, a subscript. Okay? It's not an exponent, it's lowered down, lowered down. So you can't tell me this is x squared. It's x2. It just, when we use subscripts, this just tells me something like this is 0.1 and this is 0.2. It just differentiates between points or whatever we're talking about. It's a subscript, okay? Very useful. all three of these are good, folks. You do need to know that slope is small script m. You do need to know that. So looking at page 794, it says number 2B, 794, we want the slope of the line that passes through the points minus 3, 5 and the point minus 4, minus 7. So it makes no difference. I usually label this as x1, y1, and this one x2, y2. You can do it in the opposite order, and it's perfectly fine. Okay, but do label them so you have something to see. So write your formula down, y2 minus y1 over x2 minus x1, and we get slope equals minus 7 minus 5 over minus 4 minus a negative 3. So you have to be careful there. Minus 4 minus the negative 3. So you know how to add these now. You're pretty proficient at it, and you got minus 12. In the denominator, we have minus 4 plus 3. Minus 12 over negative 1 is positive 12. So the slope of my line is positive 12. I should write m equal 12. Okay? So you might say, well, what does slope of m equal 12 mean? So this is the answer. I'm just going off to give you a little idea on the side. And so what does a slope of 12 mean? Well, remember, 12 is 12 over 1, so that's rise over run. That means up 12 to the right 1. So if I were doing this, I would go to the right 1 and then up 12. To the right 1 and up 12. That is what a slope of 12 means. Okay, it's a very steep slope indeed. On page 794, we're looking at we did B. Oh no, we did A. We did B. Sorry about that. So we'll now do C. And we want the slope of the line that passes through. Slope through 6 minus 8 and minus 2, 4. So once again, you're going to label this x1, y1, and you're going to label this x2, y2. I'm going to write my formula down. Slope equals y2 minus y1 over x2 minus x1. Now all you do is you look at how you labeled them. 4 minus a minus 8 minus 2 minus 6. So we have 4 plus 8, 2 negatives is a positive, a minus 2 minus 6, the signs are like, we get minus 8. 12 over a minus 8, we're going to reduce it, we get 3 over negative 2, but we never keep the minus sign in the denominator, so we have a slope of minus 3 halves. Remember, a minus 3 halves slope is going to look like this, decreasing, okay? A slope of 12, this is increasing. So you always want to have an idea. You want to have an idea as what your line looks like all the time. Okay? So this this is a fairly long section because there's a lot to say about slope, that's for sure. And we're going to look at page 795, number 3, and my points are 2, 5, and -1, 5. So x1, y1, x2, y2. My slope equals y2 minus y1 over x2 minus x1, and that gives me 5 minus 5 over minus 1 minus 2. Well, I say, well, wait a minute, I'm getting a 0 in the numerator. So 0 over minus 3. Remember, we did that first day, first week of school. 0 in the numerator is legal. Divided by anything, you get 0. So this says a 0 slope. 0 slope. If I plotted these 2 points, 2, 5, and -1, 5, do you see what you get? You get a horizontal line. So let's write this down. A horizontal line has slope equal to 0, whereas a vertical line has an undefined slope. You should have a good handle on this. You need to know that. And this second one, the vertical line, is the part B here, which is 3, 1, and 3 minus 4, x1, y1, x2, y2. We get slope equals and we get slope equals -4 minus 1 over 3 minus 3, -5 over 0, and we say, oh, can I divide by 0? Absolutely no. So this is an undefined slope. Big idea. These two are big ideas. Okay? We can have 0 in the numerator, but you can't have 0 in the denominator. It becomes undefined. Okay? Let's look then. So I can't do every single problem for a lot of reasons. The video gets too long, and I would never be able to do all these problems in class because part of the time I do walk-in checks, I give you a handout, you ask me questions. So I'm giving you extra examples because I don't have that question and answer period. But I can't do every single one. So now, we have another way to find slope, is that I gave you the formula to find slope, which of course is a no-fail method. But if you are given, that would be mostly for given 2 points. But if you're given the equation of the line, here is the way you can find the slope. If you look on page 796, you can look at that little green box, and it says step 1, solve for y. And step 2 is the slope is the coefficient of x. Slope is the coefficient of x. Okay? So we are given y equals -7 halves x plus 1. It's already solved. The coefficient of x my slope is minus 7/2. But on B, 4y equals 4x minus 3, I have to solve for 1y, so I have to divide by 4, and I get y equals x minus 3/4. My coefficient here is a 1. My slope is 1. C, 3x plus 2y equal to 9. I'm going to subtract 3x from each side, and that gives me the 3x's add out. I bring down the 2y, and I have minus 3x plus 9. And then I'm going to divide by 2, and I get y equals minus 3/2 x plus 9/2. And how easy is this? My slope is minus 3/2. So if you have the equation of the line, all you have to do is to solve for y, and the coefficient of x is the slope. Hold on 1 minute, I need more paper here. Okie dokie. This is going to be a big file for this lecture. I see that. So let's talk about parallel lines. Let's talk about what are parallel lines. Page 797, parallel lines. Okay, so all of you know what parallel lines look like. It could be the floor and the ceiling, for example. That's a good example of parallel lines. And parallel lines are two lines in a plane, and they never intersect. And the author has that, he has that, does he have that in here for us? Correct, on the top of page 797, two lines in a plane that never intersect. The types of lines we have, if we were describing two lines, we have parallel lines, we have perpendicular lines, and we have intersecting. So parallel, perpendicular, intersect. So those are our only three choices, is on lines: parallel, perpendicular, or intersect. So parallel lines are two lines in a plane that never meet at all. Okay? Perpendicular lines, this means perpendicular. Perpendicular lines have the product of the slopes of perpendicular lines is minus 1. Perpendicular lines have a product of their slopes equal minus 1. Perhaps that's not said as nicely as I would like it to. And so, let's see here. He might have it said better. The product of the slopes of two perpendicular lines is always minus 1. That's what you need to know, is just what I said. And what about intersecting lines? Well, their slopes are just going to be different, completely different. You know, one will be 5, one will be minus 3, something like that. Page 799. Let's look at 4, A through D. I remember I liked this question here. So you're going to have to look in your book, everybody, at the graphs. And we have, I'm just going to do it this way, 1, 2, 3, 4, like this. And so the first graph looks like this. The first line looks like that. The second line looks like this. The third line looks like this. And the fourth one looks like this. Okay? And the question, oh, I see, we had to find the actual slope of the line. My error, I thought he just wanted us to find positive or negative. Okay, so we need a little bit more information then to make this going to work. But for you, you don't have to do all this. You can just look in your book. But, okay, so the question says we're going to match these up, and it says match the graph of each of the lines, and our choices are, let's see, match the graph of each line with its slope in choices A through D. So A is 2/3, B is 3/2, C is minus 2/3, and D is minus 3/2. Okay, so he made it pretty easy for us. So this line here looks like this, and this line here looks like this. Mine won't be perfect. I'm just giving you a basic idea here. Okay, and I'll label them. Let's look at the boxes. So this point is 2, 0, and this point that he gives us right here is minus 1, 2. Okay, this point here is minus 1, 2, and then this point here is 1, 2, 3, 4, minus 4, 0. This graph is minus 1, 2, and this point down here is 1, minus 1. Okay, and this one is minus 1, 2, and this point down here is 1, 2, 3, 3 minus 1. Okay, so let's look. Immediately you can tell me if you like red or not. I remember one time I was teaching a class, a calc class, and I was using red on the board, and the student explained that red is very hard for certain eyes to see, which I think mainly would be people that have red hair. They have a certain something in their eyes, and it isn't comfortable for them. So if any of you say, don't use red anymore, I understand completely. So I look here, I would look at this. First of all, I would see, do you have 2 positives and 2 negatives? So right here, this goes from high to low. So this is decreasing. So this is a negative slope, but this one is increasing, so it's positive. And this one is negative, and this one is positive. So first of all, I would go through, and I would say what is positive and negative. Because now, if this is negative, it can only be either C or D. If you were taking the ACT exam, which is multiple choice, is that you want to do things quickly. So you would say, okay, I've limited it to C or D. So I'm looking here, and I have minus 1, 2, and I have 2, 0. So x1, y1, x2, y2. And that will give me y2 minus y1 over x2 minus x1. So 0 minus 2 over 2 minus a minus 1, I get minus 2/3, and that would be C. So this is C. Does everybody agree? So then, do you agree then this one's negative? That has to be minus 3/2, doesn't it? Okay? So now I'm left with the two positives. So let's look here. My point is minus 1, 2, x1, y1, and I have minus 4, 0, which is x2, y2. So 0 minus 2 over minus 4 minus a negative 1. I have minus 2 over minus 4 plus 1. I get minus 2 over minus 3, positive 2/3. So this is positive 2/3. So this one has to be 3/2, has to be B. But I can also show you a little different way to do it. I'm sure some of you are sitting there and saying, well, I don't have to use that formula. All I have to do is count. And absolutely, that will work as well. So this would be method 2. And so method 2 would be to count the squares. Count the squares. So remember, it's the change in y over the change in x. So on the first one, if I go this way, it's going to be 2, down 2, to the right, down 2, and to the right, I had to go from minus 1. So I had to go, go down and over here. I had to go to the right 3. Down 2 and to the right 3. So that gave me, down means negative. So I got my minus 2/3 here, which is what I agreed with. Okay? And then the second one, the change in y over the change in x, I know it's going to be positive. So I have to go from left to right, so I'm going to go up 2, and I'm going to go to the right. Oh, I'm looking at this point here. Yes, this point here. Up 2, but I'm going to the right 3, and that gave me positive 2/3. Okay? So a lot of my students like to count. Absolutely, that's fine if you have the grid in front of you. And of course, if it's not a fraction or a decimal, that always works out perfectly well for us. But I kind of like that A through D question, number 4. Okay, just also know this, let me go off to the side here, is that same slope, if two lines have the same slope, they are parallel, and if two lines have slope product equal to -1, those two lines are perpendicular, which we already covered that. Looking now on pages 800 and 801, some of these we're just going to kind of fly through, is that we're looking at, just look at your picture in the book at number 8. My line looks like this. We want to know if it's positive or negative. It goes down, it's decreasing, it is negative indeed. Okay? 10, we already talked about this, is that on 10, my line goes like this. It is increasing, so this has a positive slope for sure. Number 12, my line is horizontal, so my slope is 0. Slope equals 0. Looks like that. So look in your book as I am talking to you. 14. Okay, we have a house. The roof looks like this. We're given that this is 6 feet. We're given that from here to here is 20 feet. So that means from here to here is 10. So my slope equals rise over run, which would be 6 over 10, or, oh, he says what is the slope or the pitch of the roof? I think he has the wrong answer because, oh, I see, my mistake. It's 3, I thought his 20 was going all the way over here, but it isn't, everybody. The arrow only goes here to this point. So that whole distance would be 40. So his 20 only goes that far. So it's 6 over 20, which is 3 over 10. Because we had to use a triangle, and that would be correct. So yes, I didn't see where the arrow had stopped. Looking at number 20, the question says, find the slope. You can count the blocks if you choose. You can count the blocks, and this point, oh darn, my light went out again. You have no idea how frustrating this is. This is -1, and the y value is 1, 2, 3, 4, -4, and the other one is up here. It's 1, 2, 3, it's 3 and up 2. So you have 2 choices. You can count, and my slope is, up. So I'm going from -1 to 3. Excuse me, I'm going from -1 to 2. So that would be up 3, and I'm all wet. Forget that. That doesn't work for me. So we need to count from -4 to 2. So -1, -4, and we're at 3, 2. So I have to go up 4, up 2 more, so my rise is 6, and my run is, I have to go from -1, so I'm going up 6, and then I'm going over, so I'm going from -1 to 3, I'm going 4 to the right, and my answer is 3/2 on number 20. But if you don't like doing that, use the formula. Slope equals, it would be 2 minus a -4 over 3 minus a -1. 6 over 4, okay, is 3/2. 2 ways to get the slope. If the grid is there, it's much easier for you to count than the way I'm doing it here. Continuing, we have from number 20, let's look at 26. Okay, we've done quite a few of these. I don't know how many I need to do. 4 minus 1 and -2 minus 8. So I'm going to call this x1, y1 and call this x2, y2. And so my slope is y2 minus y1 over x2 minus x1. -8 minus a -1, -2 minus 4. And so we have -7 over -6, and my slope is +7/6, positive. So we've done quite a few of these already. You can certainly do some of them as well. 28, these numbers are easy when they have zeros in them. So my slope is y2 minus y1 over x2 minus x1. minus 5 minus 0 over 0 minus a minus 8. Minus 5 over 8 will work for us. Okay? Looking at number 40. Oh, is this easy or what? It says find the slope. It is the coefficient of the x value. Slope is 2, but we had to solve for 1y. It was already given to us. 44. 6x minus 4y equal to 4. I have to solve for y. Minus 4y is negative 6x plus 4. Divide by 4. I get, let's divide by minus 4. That'll take care of it. That'll give me a positive y equals 6/4 x minus 1. I don't really care about that constant. So my slope is 6/4 or 3/2. So you need to know how to solve for 1y. If it's already solved for you, it's a piece of cake. Remember, the test, of course, I won't be in the room with you doing it. But if you don't learn to do this yourself, you won't get done with the test, and you certainly won't be successful in the next math course you take. So please, please learn the material on your own. Okay, 50, we have x equal to 5. By this time, you should know that x equals 5 looks like this line. We have a vertical line. We have an undefined slope. Vertical lines have a slope that are undefined. This is a big, big section. Number 60. The question says, use any two of the ordered pairs to find the slope of the line. Find the x-intercept of the line and the y-intercept. So we found plenty of slopes. We're just going to skip to the x and the y-intercept. Okay, folks? We've done a ton of slopes. So he labels this for us. He labels this as 2, 0, and he labels this as 0 minus 4. So my x-intercept is where it crosses the x-axis, x equal 2, or you can write 2, 0. The y-intercept is y equals minus 4, or 0 minus 4. Okay? Looking on down now, we should recognize parallel and perpendicular or neither. Number 66, the only way we can do it is to find the slopes, everybody. In other words, that's the only way. Okay, so I'm going to solve for y. I'm going to divide by 5. And I get y equals minus 2/5 x plus 4/5. So my slope is minus 2/5. Solve for y. I'm going off the paper here. Going off my sign. Divide by 10. I get y equals minus 4/10 x plus 1/10. And this will reduce to minus 2/5. These two are the same, so my lines are parallel. They're parallel, okay? By the time you do this section, you should be pretty good at solving for one variable. I went through that a little bit fast, but by the time you get there, you should be good at doing that. So they were parallel, and then looking at 68, 68 is this. I have 8x minus 9y equal to 6, and 8x plus 6y. I need to move over. This equals minus 5. I have to solve for y. So I'm going to have minus 8x plus 6. I'm going to divide by negative 9, and I get y equal to 8/9 minus 6/9. At this part here I don't care about. I'm looking at this. Okay? Subtract 8x, and here I get 6y equals minus 8x minus 5. Divide by 6, and I get y equals minus 8/6x minus 5/6. And so my slope here is minus 8/6, and that reduces to minus 4/3. So these two slopes are not equal to each other. So these two slopes, they are not parallel. They are not perpendicular. So the answer is the word neither. Neither, everybody. That's the answer to that. So that was a huge day that we just completed here. So we did sections 11, 1, 2, and 3. Even though it was 3 sections, it really was a lot of information. So the more you do, the better you'll get at it. So I'm going to sign out here. I'm in the dark. I need to go turn on the lights. And each day I see you, I hope we're getting healthier in the world. So everybody take care, and I will see you the next lecture. Goodbye now.